Our aims in the experiment was to compare the response of 6 different temperature sensors to steep changes in temperature. We also measured the time taken for the sensors to adapt to these changes, and afterwards compared the results to determine which sensor adapted the quickest. The temperature measurements, which are both reliable and accurate, are both vital in processes in a plant. To understand the extent of accuracy and reliability, the range and response capabilities of temperature measuring devices must be understood. Different sensors will have a myriad of responses to steep changes in temperature. Our method was to first switch on the heater and the stirrer and increase the heater power to maximum. We recorded a reference temperature, which was at 20 degrees. At this temperature, we took the readings for each sensor in 5-second intervals, whilst in the water bath. Then we placed the sensor carrier in the cold water and took readings of each sensor. We placed the sensor carrier back into the water bath and heated the temperature to 22 degrees, and repeated the sensor reading in the water bath and the cold water. Then we repeated this for temperatures of 55 degrees and 100 degrees.
There were 6 different temperature sensors we looked at in this investigation, all with varying materials and methods in measuring temperature. We looked at a liquid industriometer, which has mercury sealed within a glass bulb and temperature of 0 to 100 degrees Celsius. We also looked at a thermocouple, which has a range of metal alloys due to the different types from E to G. Some can measure below minus 200 degrees, and some can range up to 1700 degrees and measure temperature using Seebeck effect. We looked at the RTD, which stands for resistive temperature detector. We looked at the ones for PT100 and PT100 industrial and reference. These ones have platinum with coiled around support structure, and the difference is because they have one is 10 millimeters and the other is 2 millimeters, and have the ranges set here. Also, we looked at a thermistor, which has a sintered metal oxide and temperature ranges from 0 to 100 degrees Celsius.
These are the results we obtained from our experiment. From these results, we were able to produce the following graphs.
From these results, we have deduced that the thermocouple adapted the quickest to temperature change, as the graph has the steepest gradient and the greatest difference between the lowest and the highest point, meaning it was the most sensitive to temperature change from cold environment to hot environment. It took the least time to stabilize. On the other hand, the PT100 industrial took the longest time to stabilize. It has the shallowest gradient, meaning it was less sensitive to sudden change in temperature, and for this small temperature range, which was from 20 degrees Celsius to 100 degrees Celsius. This may indicate that it is more useful when larger temperature changes are present.
So in a situation, for example, where you had to heat something for it to melt and then mold, and then it had to be rapidly cooled for the substance to be solidified, the best sensor to measure temperature for this environment, we believe, would be the thermocouple, calibrator, or the thermistor, as these are the most sensitive to temperature changes and adapt the quickest. P200 industrial would be the least effective, as these are the least sensitive and slowest to adapt to temperature changes from very hot to very cold.